In this video, I will discuss measurements. The most common measurements obtained during experimentation are mass, volume, density, and temperature. First, let us discuss mass and weight. Mass and weight are often used interchangeably, but the two terms have different meanings. Mass is the amount of matter in an object. The mass of an object is a fixed quantity that is independent of the object's location, while weight is the pull of gravity on an object and depends on object's location. For example, an object with mass m has a weight of W sub 1 on Earth. On the Moon, it will have the same mass but a different weight. For example, its weight will be W sub 2 because the pull of gravity on the Moon is different from that on Earth. Therefore, we can say that two objects of equal masses will have equal weights if they are measured in the same place. The mass of an object is measured using weighing balances, which may be of different types with different certainties. For example, the triple beam balance is accurate to 1 decimal place in grams, while the top loading balance is accurate to 2 decimal places, and the analytical balance is accurate to 3 decimal places. So that is mass and weight. Next, we have the volume. Volume is the amount of space occupied by an object. One of the laboratory wares commonly used to measure the volume of liquid is the graduated cylinder. The interface of a liquid in any glass container is usually curved, a phenomenon that results from the difference in the attractive forces between the liquid and the glass. This curvature is called the meniscus, which is carefully observed to obtain a liquid's volume with minimal error. So we have here an image which shows meniscus. So the curvature on the top of the liquid, that is what we call the meniscus. If the liquid is light colored or is colorless like water, the volume must be read from the lowest point of the concave meniscus. So just like on the image, that is an example of a concave meniscus. So it will be read from the lowest point of the curve. For convex meniscus, produced by few substances such as mercury, the volume is read from the top of the meniscus or from the highest point of the meniscus. For regularly shaped solid, the volume is obtained by V is equal to L times W times H, where V is the volume, L is the length, W is the width, and H is the height. For example, a box with the dimension 15 cm width, 25 cm length, and 5 cm height, what is its volume? So we have a width of 15 cm, a length of 25 cm, and a height of 5 cm. So getting its volume, we just have to multiply its length, width, and height. So that is 25 centimeter times 15 centimeter times 5 centimeter, which is equal to 1,875 cubic centimeters. So we have here a table which shows the volume of different 3D shapes. So we have cube, which is in the formula a cube, where a is a length of the edge. For rectangular prism, just like on the example a while back, that is length times width times height. For a cylinder, that is pi times r squared times h, where r is the radius of the circular face and h is the height. For a cone, that is 1/3 times pi times r squared times h, where r is the radius of the circular base and h is the height. Then for a sphere, we have 4/3 times pi times r cubed, where r is the radius. If the solid is irregularly shaped, the volume can be measured through water displacement method. The object is totally submerged in water in a graduated cylinder or beaker. If the object floats, a thin pointed instrument is used to press the object down until it is fully covered by water. The water level before and after placing the object are read. The difference in the two readings gives the object's volume. This happens because the object pushes the water out of its way and displaces it with its own volume. Note, however, that this method cannot be applied for solids with hollow interior such as a small ball. So as we can see from the image, we have a graduated cylinder filled with water. So it was filled up to 200 ml. Then, an object was submerged from the water. So from 200 ml water, it rises and becomes 300 ml. So getting now the volume of that irregularly shaped object, we just have to subtract the final water level and its initial water level. So the final water level is 300 ml, then the initial water level is 200 ml. Subtracting them, we'll be having 100 ml. Therefore, the volume of that irregular shaped object will be 100 ml. That is what we call the water displacement method. Next, we have density. Some objects float in water, while others sink. This phenomenon is explained by density, which is an intrinsic property of matter. The density of a material is its mass per unit of volume it occupies. In equation, we have the lowercase Greek letter rho, which is the density, is equal to m, which is the mass, divided by v, which is the volume. Densities of solids and liquids are usually reported in grams per milliliter or grams per cubic centimeter. Those of gases are in grams per liter. For example, a small statue has a mass of 78 grams and a volume of 35 cubic centimeters. What is its density? So we have a mass of 78 grams and a volume of 35 cubic centimeters. We will find for its density. So density is equal to mass divided by volume. So we have a mass of 78 grams, then divide it with its volume, which is 35 cubic centimeters. Therefore, density is equal to 2.2 grams per cubic centimeter. Another example, what is the volume of a sample of liquid mercury that has a mass of 76.2 grams? The density of mercury is 13.6 grams per milliliter. So in here, we will find for the volume. So the given are mass and the density. So substituting now density and the mass, so that is 36.6 gram per milliliter, which is the density, is equal to 76.2 grams, which is the mass, then divided by the volume, which is the unknown quantity. Then cross multiply, so 13.6 grams per milliliter times volume or V. So that is 36.6 grams per milliliter V is equal to 76.2 grams. In order for us to solve for V, let us divide both sides of the equation by 13.6 grams per milliliter. So that is now 13.6 grams per milliliter V divided by 13.6 grams per milliliter. So, makakancel na yung 13.6 grams per milliliter because that will result to 1. Then 1 times V, that will equal to V. So, V now is equal to 76.2 grams divided by 13.6 grams per milliliter. So, that is 5.603 milliliters. So, yung gram, makakancel din yan because grams divided by grams, that will be equal to 1. Then you multiply it with 5.603, which is also the same with 5.603. So the volume is 5.603 milliliters. When an object floats in water, it has a density smaller than that of water. When an object sinks, it is denser than water. We have here a table which shows the densities of some substances. So we have the substances sugar, table salt, aluminum, iron, copper, lead, mercury, gold, human fat, cork, water at 4.0 degrees Celsius, ice at -10 degrees Celsius, together with their corresponding densities in grams per cubic centimeter. Question: which will float in water, mercury or human fat? Why? So we have three substances which are water, mercury, and human fat. So alin daw sa ano daw ang lulutang sa tubig? Is it the mercury or the human fat? So let us look for the density of these three substances. So we have the density for water, which is 1.000 grams per cubic centimeter. Then for mercury, we have 13.6 grams per cubic centimeter. And human fat, we have 0.94 grams per cubic centimeter. As I have said a while back, an object will float in water if it has a smaller density than that of water. So which among mercury and human fat has a lesser density than that of water? It is human fat. Therefore, human fat will float in water than mercury. So mercury will sink in water because it has a higher density than the water. And lastly, we have the temperature. So temperature is the measure of hotness or coldness of matter. It indicates the energy of the particles in a substance. For example, the water molecules of hot water at 60 degrees Celsius are more energetic than those in cold water at 5 degrees Celsius. Heat and temperature are related, but they are not equivalent terms. Heat is the total energy that results from the molecular motion inside an object, while temperature is a measure of the average heat or thermal energy of the particles of an object. So it may be expressed in degrees Fahrenheit, degrees Celsius, or Kelvin. We have here the following conversions on temperature. We have from degrees Fahrenheit to degrees Celsius. That is, degrees Celsius is equal to the quantity degrees Fahrenheit minus 32 divided by 1.8. That is, degrees Fahrenheit to degrees Celsius. Then, degrees Celsius to degrees Fahrenheit. That is equal to, so degrees Fahrenheit is equal to the quantity degrees Celsius times 1.8 plus 32. And lastly, we have degrees Celsius to Kelvin. So Kelvin is equal to degrees Celsius plus 273.15. Example, convert 75 degrees Fahrenheit to degrees Celsius. So we'll be using the formula degrees Celsius is equal to the quantity degrees Fahrenheit minus 32 divided by 1.8. So the given is 75 degrees Fahrenheit. So from the formula, we just have to change degrees Fahrenheit with 75. So that is now degrees Celsius is equal to the quantity 75 minus 32 divided by 1.8. That is 43 divided by 1.8, which is equal to 23.89. Therefore, 75 degrees Fahrenheit is equal to 23.89 degrees Celsius. Another example, what Kelvin temperature corresponds to 10 degrees Fahrenheit? So we need to convert degrees Fahrenheit to Kelvin. So basing from our conversions a while back, there is no direct conversion of degrees Fahrenheit to Kelvin. But instead, we need to convert first degrees Fahrenheit to degrees Celsius. Then from that degrees Celsius, we will convert it to Kelvin. So, first, convert degrees Fahrenheit to degrees Celsius. So that is, degrees Celsius is equal to the quantity degrees Fahrenheit minus 32 divided by 1.8. So replace degrees Fahrenheit with 10. So that is the quantity 10 minus 32 divided by 1.8, which is equal to negative 22 divided by 1.8. So 10 degrees Fahrenheit is the same with negative 12.2 degrees Celsius. Then from this degrees Celsius, we will now convert it to Kelvin. So Kelvin is equal to degrees Celsius plus 273.15. Then substitute negative 12.2 with degrees Celsius. So that is negative 12.2 plus 273.15, which is equal to 260.95. Therefore, 10 degrees Fahrenheit is equal to 260.95 Kelvin. So those are some measurements used in chemistry. Thank you for watching, and I hope you have learned something.